Hello, I'm Elliott Zaresky-Willaims, CTO and co-founder of Neurales, and this presentation will be talking about the NLM, which is the Neural Lambda machine, and the future of software development. And this presentation will be geared more towards investors and prospective clients. So exactly the way the presentation is going to be broken down is first we're just going to talk about why we would need the NLM, and then the second part will be how does it work, and the third part will be showing it off a little bit, and then also the business model. So let's start. Why do we need the NLM software? These are important questions that we all could ask ourselves because really software development is very expensive and there are a lot of questions related to the building of it, the maintaining it, and really anything that goes into that. So how much money do we think people spend on software development, on let's say it's the US and Canada, it's, order of, tens of billions, if not more. And then how much money is spent on, let's say, in mid to large size companies on software development. So it's another huge number. See, the answers to these questions are, we know they're very large numbers. And the third question is also very important. How many software projects actually fail to deliver as promised on time and on budget? That is definitely a big question to ask ourselves. And then the final question is how much legacy code exists, how expensive it is to maintain it, how much would it cost to modernize it? We're going to keep those questions in mind as we go through the rest of the presentation. So pretty much the NLM is just a software pipeline which utilizes a proprietary deep learning framework that was developed here at Neurales by me. Essentially, it's able to learn working programs from data structures and data alone. So what that lets you do is lets you automate mundane tasks as well as some advanced software tasks. And then also the NLM is able to auto-generate source code in any programming language, and they're going to seamlessly integrate into any CI/CD pipeline. So this is going to be, for investors who have some background, let's say no-code or low-code solutions, this is definitely going to be something different. We're going to show exactly why it's so different in the rest of the presentation. There are really two types of NLMs that actually have been developed here. So there's a type 1. This essentially learns the program by encoding it in the model parameters. So you have some kind of deep learning model that's the NLM, I guess the brain, if you will, quote unquote. And then essentially you feed the data into this model directly, and the program is performed by passing the data from input to output. So essentially, normally you have, let's say, a program written by a software engineer. You're replacing that entire program just with the NLM type 1. That's well trained. And then type 2 is where it selects between known programs and it optimizes time and memory efficiency based on input. So let's say you have some data structure and then you want to determine what algorithm you want to use to solve it. The type 2 will be able to optimize that for time and memory efficiency. And so again, let's say even if you're developing software, you're not really sure how to optimize a particular part of your code base. You're going to get some kind of data. You're going to use one of, let's say, 5 algorithms. How do you know which one to use in all cases? Do you want to code for that? Do you want to sit around and think to figure out how to code for that? No. You're going to use the NLM type 2 to optimize the memory and time efficiency. And depending on your hardware limitations or time limitations, you can, of course, gear the NLM to prioritize memory or time, and you can control that during training. This is really kind of like the diagram which really shows how this all works. Part 1 on the left here, it's really just user data. So pretty much this can really come from anyone's computer. It can be a remote database or server, and then that's fed through the NLM. And so pretty much then we just learn the program. So it's a spit. So you train it in here with this little AI graphic for the NLM, and it will spit out a working program. And then as soon as it's done training, it will actually just auto-generate this code. And then of course the output, and then of course after that you get the output of the program. You can put this, this can be translated to a language, and then you can then output the results that you want. And you can optimize, a sorted array, which actually we're going to show a demo of later. And then, or it can be a web app feature, or really anything that modifies the supply chain pipeline. The tech is very new, but we're going to show that it can really do all that it's hyped up to do. There's also type 2. So type 2 is the same idea. You have user data, but in this case, the NLM chooses between, let's say, in this graphic, 3 known programs, and then, it selects the best one given the choices, and again, optimizing for time and memory efficiency, and then the output. So it's really they really act very similarly, just sort of what the input and output is to the NLM specifically may change. So it's really, it's a modular and hierarchical build. So it's not really it's not limited to learning just technical algorithms, that you might be interested in like a lab or whatever. It can be used at high levels of software abstraction. So it can implement, let's say, dependency inversions. So this is other sophisticated design patterns. So basically, it's not just simply saying, I want to learn a simple basic function that I run in a programming language. Let's say entire pipelines can be thought of as a program to optimize with the NLM. So because it can work at multiple levels of hierarchy, and it's modular, that is a super nice selling point for the NLM. So let's just show it off. So first, before we get to the actual demo, I just kind of want to show a couple of maybe more practical use cases that could really demonstrate how this can be used in practice. So here we have, let's say, let's just take a machine learning workflow. So typically, you have a data set. You go to some machine learning pipeline, and then you go to some file system or cloud storage. This is for large industrial projects that really require cloud infrastructure from like AWS or Azure for Microsoft. And then of course you deploy the models, and this is typically done with something like Kubernetes. And then you also give like API requests for clients. So this is like a typical industrial application of some machine learning project. So how will this work with the NLM? So we of course at Neurales we already have our own app that sort of automates some of the a large portion actually of the machine learning pipeline. So really step one, you have the user, they have some data, or just any information that's going to be then used by Neurales can just be in part one of this flow chart. And then so step two, model pipeline, that's done by the Neurales backend. The step three, which is the output, like files, model metrics, and whatnot, that can be just dumped to Amazon S3 bucket. And then 4 is a model deployment, which is SageMaker. And again, this is all done by our app already with some caveats. It's obviously still under development, but this is what the app is doing. So then the NLM, what it can do is it can choose between multiple Neurales configuration files, and that can go from, let's say, choosing data sets. So basically, a lot of these workflows that's really in step 4 especially. So Kubernetes will let you actually take, you'll be able to do multiple processes in Kubernetes, but then the NLM here can then say, I'm going to optimize which processes I do and when in a certain order, and then this will actually then accelerate how fast these models can be trained and deployed into production, as well as also model maintenance in real time. That's again something that NLM could do, and of course, any questions about how that can be done in more detail, you can just obviously email us and we'll discuss some more. But it can do all that. And of course, finally, there's a nice little API gateway. So this is for the user to interact with Neurales, and then this is like a real-time communication. And then of course this is pulling from this little pipeline here. Another important question, or really another important application, really is auto-generating, let's say, unit tests and integration tests. So of course, writing unit tests are nice because they can ensure code stability, but they take time and resources. And oftentimes, this may not be worth it for a company. Like the cost-benefit analysis may not simply be desirable. And so they say, we're not going to write unit tests because we don't have the time and money to do it. But of course, ideally, if they could just have them without having to pay anyone, that's desirable. So, of course, the NLM can also learn to auto-generate reliable unit tests in any language. So that's another selling point. Another demo that we're actually going to start having soon is hopefully in the next 1 or 2 months. We have a COBOL to C++ compiler. So pretty much, learning to translate from one programming language to another is very hard to do. Like normally you have to take, teams of people who have a lot of expertise to be able to actually build these source-to-source compilers. And then off-the-shelf ones may not be desirable. There could be some limitations, hardware-wise, or any part of the software pipeline could be also a problem. So something off-the-shelf may not be what you want. And of course, modernizing COBOL code to say something like C++ is desirable because a lot of legacy systems, in banks and certainly government use a lot of COBOL. And so because of that, if they can modernize it to something like C++, that could be a great benefit. And again, the NLM will be able to do that. And of course, even just maintaining legacy code is super expensive. The NLM can also, there are numerous ways this can be done here. We're not going to talk about all of them in the presentation, but it can also be done. And of course, obviously, if for this particular task, if translating large chunks of COBOL C++ was as easy as just using an off-the-shelf compiler, it would already been done. This problem wouldn't exist. And so really, this is going to be an auto code generation example with the NLM. So first, we have some configuration file. So this is, this file, the user can of course modify any one of these arguments. And then what happens is this will help create the NLM as well as set up data pre-processing, data post-processing. And then, of course, input variable names. So the program that's auto-generated at the end of the process, you can choose the variable name you want it to have. You also can, of course, name the program you're learning. We're just going to call it name sort. We're, of course, going to auto-generate it in Python. And, of course, this is just these are directories that you actually save the data to. So all of these arguments here are just configuration files that help with the training of the NLM and also help it auto-generate in source code that is desirable. So this video will kind of just show the NLM, again, learning to sort in real time. We already have demos like this on our website, but I'm just going to show a little bit of this and then sort of maybe fast forward towards the end. But let's give it a second to load. So of course you see here down over here we have some arrays and we have a predicted sort. So the NLM has successfully learned to sort. So Why this is a big deal? Because normally people have to write a sorting algorithm. Now sorting is kind of boring, right? Because we already know how to sort. But let's suppose we did know how to sort. Let's suppose that we never heard of a sorting algorithm ever in our entire life. We never wrote one. So rather than writing one, the NLM has actually learned the program just from data and the data structures alone, from nothing else. It doesn't need any human input to learn how to do this. So obviously it's going to run. I mean, it's already pretty well trained. The NLM trains pretty quickly. I'm just going to kind of fast forward towards the end here. And then at the end, we have, let me just pause it here. So model weights. So the model weights are going to correspond to the learned program. So like I said, with type 1 NLMs, the entire program is encoded in the model weights. And the file, so this file is going to be the auto-generated code, the source code. So let me just go to the next slide. So again, this is the directory. You know, we have the NLM weights. This is where the actual model, this is where the actual program, the behind the scenes lives. And then we have a text file, which will actually be the source code. So this is what it looks like. So here, you know, we have NLM sort. You know, we have a couple libraries that we're importing. You know, this is just a little information. You know, it's learn sort. We have an associated program confidence. So one thing that I didn't touch on in this presentation, but I commented on in earlier videos on our YouTube channel, the NLM actually also has a confidence mechanism. So it actually can tell you how confident it is with the program that it's learning. And of course, you know, it tells you where to find the weights, and of course, it's timestamped. So you know exactly when it was trained, and you know what day it was, and everything like that. So, and over here, you know, you have just your config files, configuration files, and of course, look, learn sort. So this right here. Oh, sorry, let me go back. So this learn sort is the name of we want to call the program or the function that we're learning, learn sort. And of course, here ARR, the array. If we go back a couple of slides. Notice that we, down here, an input variable name, we want to call it that. We, of course, can change that and call it whatever we want to, but this is where, you can see the configuration file is at work here. And this is the program, right? And then, of course, obviously, we're just going to load it into Python. Remember, we auto-generated the code in Python. And so we have, again, this is just, and you can see it's just syntactically nice. You know, it's all clean, and, you know, the code is exactly what you would want it to have. And so one thing I definitely want to stress here is that we learned how to sort, but every single program that the NLM could learn is going to be exactly this short of a program, because what's happening is when these lines down here, which is, you know, data, model load, all this fancy stuff, the maximum number of lines that the NLM that the source code is going to have is going to probably be like 10 lines of code. Like this is as for every program we can learn is going to look like this. We're going to, of course, have different names, but any program we can learn is going to always be this large. It's not going to be some humongous source file. It's going to be something very clean, very short, and we can obviously add comments and do whatever, but it's going to be that simple. So every program we can learn will always be like this. And of course, we're going to test out some code. So down here at the bottom, you know, I just gave it some random arrays, and down here you can see that actually it's sorted correctly. And another thing I want to stress actually is that the NLM initially, if we go back to the configuration file, was actually only trained on basically integers that go from, let's say, 0 to 30. So basically numbers no bigger than 30. It was trained to sort those. But if you look here, it actually could sort numbers that are in a higher range. So it learned something more general than just the data it was trained on. So it really is very robust, and it actually is learning something beyond what we're training it, which is, I think, pretty cool aspect. So that's pretty much how this goes. So before I get to the next slide, I'm going to talk about sort of where this came from, and then finally we're going to touch on the business model, because that's, of course, what we want to get to. So, of course, I might have done these slides a little bit out of order, so I'm going to just go to this slide first, so the timeline. So in 2016 and 2018, Google DeepMind invented the neural Turing machine and what's called the differential neural computer, and this is actually where the neural Lambda machine was inspired from. So pretty much it showed that deep learning frameworks could actually solve algorithmic problems, so they could actually be applied to learning code that people normally have to write. And this is something that was big because this is not something that deep learning was excelling at before. You know, they're good at computer vision, you know, they're good at some natural language processing tasks, but they were not good at learning how to do algorithmic tasks. That was something that was just not done before. And of course, but unlike the neural Turing machine and the differential neural computer, there are some architectural advantages. So there's a lot of stuff that's going on behind the scenes which make it better technologically, which we're not going to talk about here because obviously that's more technical, not really the purpose of this presentation. So, but on a basic level, how do they compare? So DNCs, differential neural computers, can usually take 48 plus hours on a NVIDIA GTX 1080, and that's $800. And that's so basically the point I'm getting at is that it's very hardware intensive to train these models, and the NLM is trainable less than 15 minutes on a CPU for some tasks, and it also has a very flexible setup. So there's again more technical details behind the scenes, but it's not hard. You can train on a CPU. That's the definitely takeaway point. You're training on a CPU and in very little time. Another issue is that the DNCs exhibit noteworthy training instability, so it's actually very hard to train them. If you actually were to go online and look at GitHub repos and you see people running experiments, a lot of them have commented on how it's a little tricky to train them. So it's not straightforward exactly how to use them or how to apply them reliably. Whereas the NLM does not have that same issue. So it took a little while to get it to that stage, but it doesn't have that same issue. So notice that this is I bolded this for a reason. All the algorithms that the NLM has been able to learn have been reproducible, accurate, and NLM has an associated confidence in the learned algorithm. And the DNC does not have this mechanism. There's no confidence in the learned program. And of course, it's also it's more of a theoretical model. It hasn't really been able to auto-generate source code. You could theoretically build a pipeline to do so, but it's not as clean as the NLM. So that's why this is superior, both in a technological standpoint, from a technological standpoint, and also from a practical standpoint. So, and then let's just talk about how this differs from other low-code solutions. So, okay, at this point, we know the NLM, we know that it can auto-generate source code, it can learn any program in theory. Obviously, there's caveats to this. It's hard to actually learn all these things, learn these programs. It's hard, but that's sort of an ongoing R&D effort. With more funding, we'll be able to accelerate the development of this. But certainly, if it can learn a program, it's very clean, very fast, very easy, and it's learned a wide variety. So, from other low-code and no-code solutions, so first of all, these learned programs could actually be faster than the human design. So let's say you have some low-code or no-code solution. So that's written by people who have written other code to automate the code that you want to do. Now, but when they write this code, it may not be optimal. It may not be designed to be super fast, whereas the NLM, especially if you do type 2, can actually learn to optimize the code. So actually, the learned programs from the NLM could be faster than what humans are going to be designing. And so they're not very efficient all the time. And of course, they're more universal. Because the NLM is always going to follow that same exact output format, like I'm just going to briefly go back to here. So it will always follow this output format. And also, in case that anyone's had a question, the type 2 is going to look very similar to this. So this is, of course, a type 1 output file, but the type 2 is going to look very similar to this as well. Okay, so it's, of course, you don't have to actually learn how to use any low-code and no-code tool, because each low-code or no-code tool, there's, of course, a learning curve. Some of them are not very hard to learn. Some of them take a little bit more time to learn, but there's still a learning curve, and they're only good at a specific subset of tasks. So they're specialized. They're obviously not general. That's the challenge. And so, and that's really a huge perk. And so the NLM really benefits everyone, right? Because whether you're an advanced software engineer who wants to just, really build really sophisticated software applications and really anything in between, let's say you don't even have any developers. Let's say you're a restaurant. Let's say you want to analyze your sales or something else. And you want to have code that'll do that, but you don't want to pay any developers. The NLM could also do that. Obviously, that might be a bit of a contrived example, but it can benefit people who have huge teams of software developers and companies which have no software developers. So there's definitely a use case for all those people. And again, if you have any questions or want to know more about the details, obviously just email us. We'll talk more about that. And again, finally, this kind of is probably clear at this point, but it's more modular than other low-code, no-code solutions. And then, because again, like I was saying, it's specialized for a few use cases. And so that's why it's truly general. Because the NLM could learn any program, and because it's also learned to optimize for that, it's actually low code or no code, depending how you look at it, really. But because it's so general, that's why it's new. That's why it's new and has value. It's other low code solutions are too specialized, or it's not good, or they are not efficient. And NLM addresses all three of those problems. So the business model, again, let's just kind of stress who the customers are. Companies that have a lot of legacy code, and of course I wanted to insert statistics here. I didn't get around to it, but I'm sure, I think most people will probably agree that there are a lot of companies with a lot of legacy code, and that is expensive to maintain. For example, again, COBOL and other programming languages, it's hard to find people with expertise in that. And let's say you wanted to, write some unit tests, or again, translate it to C++, or anything along those lines. That's hard to find people who know how to do COBOL. And again, let's say even just startups. So startups let's say they want to hire human software developers, and of course this applies to us as well, but they can't afford to. So this actually can rapidly accelerate software development and other new cutting edge tech, because you're not spending so much time writing annoying boilerplate code, because you're able to auto generate a lot of the boring code with the NLM. So let's say you have a really cool tech idea, and it's going to be very expensive to actually build a prototype. The NLM can simply accelerate that timeline dramatically. And again, even just contractors, let's say you have some deliverables, let's say the customer, keeps changing what they want. You don't want to have to go back and redo a whole bunch of code. The NLM can really help dramatically reduce how much, redundant code you have, or if you have to go back and change something, it's not too hard to do that. And again, really, the possibilities are endless, and it probably is actually difficult to really articulate all the best use cases for the NLM because the technology is so new. But certainly, the possibilities are indeed endless, and certainly as we think more about the NLM and apply it to more cases, we'll probably be able to really hone in on some really super exciting use cases. And let's say, and of course, how would we use invested money if we were to get it? We have we primarily sales team, and we have 20% will go to that, and the 80% will go towards development. And we obviously want to roll it out as soon as possible. That's really it's pretty straightforward what we're going to do with the funds. And so the milestone that we're having is going to be February 2021. Oh, I kind of did this a little bit maybe out of order. No, I did this more or less in order actually. So in 2021 we did prototype testing. The NLM has existed since November 2020, but we started testing in 2021. And these are sort of timelines. In April it was split into type 1 and type 2. In June, the auto code generation tool, which of course is this text file back here. That tool is it's kind of complete. And 2021, in July, we want to completely automate that. Right now, of course, it only works for Python right now, but of course, it's not too hard to take what we did in Python and generalize it, let's say C++, or even Java, or let's say something like maybe even Julia or Haskell. Like it can be done. It can be done. Obviously, funding accelerates the timeline. And of course, then in August, we hope to actually start using the NLM to actually design apps and show up how people can actually build apps in real time within their Lambda machine. It's really all coming attractions. Hope you guys enjoyed this presentation, and any questions, just always email us, and we'll see you guys as we start building this out more. Thanks for listening.